There's nothing like a nice relaxing game of fetch with your dog on a sunny day, unless you're the dog. Fetch is great for humans because it's a good way to get some exercise without having to put much thought into what you're doing. But if you're a dog, it requires intense focus, quick thinking, and complex language skills. After all, you have to figure out what your human is trying to communicate to you with that strange string of verbal and nonverbal cues. Not to mention the fetching part can be pretty tiring. But one thing that might make things a little easier for dogs who play fetch is a recently invented smart ball that doesn't require a throw at all. It's designed to move around on its own, which means you can just kick back and relax while it brings itself back to you. And it does this with the help of a very surprising invention, one that we've actually known about for centuries. You see, the trick to making this ball do the seemingly impossible task of fetching itself is a magnetic field. We've known about magnetic fields for thousands of years, ever since people discovered the natural magnets inside of lodestone rocks. These rocks have unpaired electron spins that align with each other, turning the rock into a giant magnet. And we've been using them to orient ourselves for hundreds of years by using something called a compass. Compasses work because these magnetic north-seeking needles are free to rotate in more than one plane. So instead of showing only up and down, they end up tracing circles around the Earth's magnetic field lines. This lets us use them to find our way in any direction, which is pretty handy when you're lost in the woods or sailing on a boat in the middle of the ocean. But while compasses are simple devices, we don't actually know exactly why the Earth has a magnetic field. It wasn't until the 1960s that we figured out that it was generated deep within our planet. The Earth's core is mostly made of iron and nickel. And as these elements move around due to convection currents, their unpaired electrons align, creating a giant dynamo that produces a magnetic field. And even though the Earth's core is about 5,000 degrees Celsius, the magnetic field is constantly shifting and changing strength due to interactions with the Sun and the movement of our planet's tectonic plates. This makes it really hard to predict what the Earth's magnetic field will do in the future. And that's a big problem for the folks who make compasses, because over time, the Earth's magnetic field can shift enough that a compass won't point north anymore. For instance, between 1989 and 2003, the magnetic North Pole moved from Ellesmere Island in Canada to northern Ellesmere Island, a distance of about 400 kilometers. That doesn't sound like much, but it is actually the biggest recorded change in the North Pole's location in less than a century. And it's happening faster than ever before. Scientists think the magnetic North Pole could end up anywhere in the Arctic Circle over the next 100 years. So scientists have had to develop new ways to measure the Earth's magnetic field in order to keep compasses accurate. Enter the Octans, a team of engineers and scientists who wanted to make a compass that would let you down no matter where you went or how fast you were moving. To do this, they created a sphere with 9 tiny compasses embedded in it, each of which points to a different direction. Because there are so many, they were able to average out the readings and cancel out the errors caused by the Earth's fluctuating magnetic field. And since the sphere shape means that there's no top or bottom, it works whether you're holding it sideways or upside down. In fact, this compass is so good that you can even spin it around really fast and its lines still give you an accurate reading. That's pretty impressive, but it raises another question. What if you take this compass to Mars? After all, Mars has an iron core too, so shouldn't its magnetic field interfere with Earth's? And the answer is yes, but not in the way you might think. You see, the Earth's magnetic field is partly generated by the movement of our planet's molten outer core. But Mars doesn't have a liquid outer core. Its core is solid, which means that the only magnetic field it has is the one left over from the planet's formation, which has long since been buried under its surface. So while Mars might have some magnetic interference close to its surface, farther up it's very weak. In other words, this super accurate compass should work just fine on Mars. This is one of those inventions that makes you wonder why we didn't think of it sooner. And it's just one example of the cool tech that makes our world go round.